Hi folks, today we're doing calculations with significant digits. Let me start by saying you're going to have to take notes on this. This is a biggie, another one of those biggies. Tends to be a long podcast, I'm sorry, but we have to do a lot of calculations, and sig figs are something you are going to see every day, all year. All right. So just kind of a reminder with sig figs, we have to look at these things and be able to tell how many sig figs we have. Remember our Atlantic-Pacific rule, right? Let me just kind of put that up here, my Atlantic-Pacific rule. If the decimal point is absent, we start on this side. If the decimal point is present, we start on this side. So here our decimal point is absent. So we start on this side for our first non-zero digit, which is the 3, and we count all the way to the left. So there are a total of 4 sig figs here. All right. What I'd like you to do is pause the podcast, see if you can do the rest of them. All right, welcome back. Here we start with the Pacific rule. We start on the Pacific side. We have 4 significant digits here. Here the decimal point is present again. We start on the Pacific side. We start with the 5. There are 3 significant digits here. Here the decimal point is absent, so we start with the 6. We're going to our left this time. We only see 2 significant figures here. Here we start on the Pacific side, the left-hand side. We find the first non-zero digit. That's the 3. There are 4 sig figs here. Decimal point is present again, so we start on the Pacific side on this side, and we count to the other ocean. There are a total of 6 sig figs here. Here the decimal point is absent, so we start on the right-hand side, the Atlantic side. We count the other way. There are 3 sig figs here. And final one does have a decimal point, so the decimal point is present, so we start on the left. We find the 4, and we have a total of 5 sig figs here. All right. So how do we use sig figs when we're trying to multiply and divide? This is the easy one. All right, what we do is we take the 2 numbers, we multiply or divide them, or the 3 or the 4, however many numbers you have. We count the total number of significant digits in each number. And whichever one is smallest, that's what limits us on our final answer. So our final answer should have no more sig figs than the lowest number of sig figs you started with. So let's do some examples. That's the easiest way to do that. Let's take 6.7 times 1.1. We multiply those 2 numbers out, and we get 7.37. But we look at the first number here, the 6.67, and there are only 2 sig figs here. There are only 2 sig figs in this number, which means our answer can only have the lesser of those, which is 2 sig figs. So the 7.37, we have to round to only 2 significant digits. Yeah, if you don't remember how to round, again, go back to Unit 1. We talked about that back then. I told you, everything builds in here. Right, so we have to round to the 7.3. The 7 is a 5 or greater, so we round the 3 up, so it becomes 7.4. So our answer is 7.4 moles to the right number of sig figs. All right, let's try another one. We have 3.3 divided by 1.1. Now, you're very tempted when you do this to say, well, that's 3. Okay? No, it's not. There are 2 sig figs here. There are 2 sig figs here. Our answer has to have 2 sig figs, which is 3.0. 3 doesn't cut it. Okay? So it's got to be 3.0. Let's go through some examples. Right? These are rather large for just doing without a calculator, but just kind of to work it out, I take 35.72 and I multiply 0.0032. Now I'm going to multiply this out, and I've already done that, right? And my answer here is, thank you, 0.114304. But up here, I look at this and I have 4 sig figs. Up here, I only have 2 sig figs. So my answer can only have 2 sig figs. And we look at our next one, and that's a 4, and the 4 is less than a 5, so we're going to round down, so we're going to leave it at 0.11 is going to be our final answer with 2 sig figs. All right, let's look at this one. How many sig figs do you see on the left? Well, I see 4 sig figs on the left. How many sig figs do I see on the right? Be careful. The Pacific rule says I start on the left-hand side, the Pacific side. I find the first non-zero digit. I count to the other ocean. There's a total of only 1 sig fig here. So when I multiply this out, I get 0.1997, but I can only have one sig fig. So I'm going to have to round to this digit, and because the 9 is greater than 5, the 1 goes up to a 2. So my answer is going to be a 0.2 as my final answer. Again, you can only have one sig fig. I realize when you sit down and you use a calculator, you come up with this number over here. Okay? But that number is wrong. I mean, mathematically it's right, but you only were able to measure this first number up here to one sig fig, which means you can only have one sig fig in your answer. Let's try one more. Right? How many sig figs do you see here? Yep, you see 2. And how many do you see here? Well, a lot more than 2. That's over 5. All right, so how many sig figs does my answer have? Yep, only 2. So even though it comes out to this nice big long number on my calculator, I have to round. 8 has to go up, so I have to round to the 0.19. Okay. Now, division works exactly the same way as multiplication, so I'm going to ignore it. Adding and subtracting is completely different. I'll warn you, adding and subtracting, we are not counting sig figs. And that's what you've been trained to do, but we're not counting them in this case. What we're doing is we're adding the numbers, just like you'd add them up back in grade school. When you were in 3rd grade and you learned to add decimals, that's what we're doing. You round the decimal to the least number of decimal places. Actually, you round it to the least, the digit that has the least significance. All right? So let's look at this. These zeros are significant. These zeros we measured. Remember, this number has 4 sig figs. These zeros actually mean something. And the 352 also actually means something. So if I look out here at this 0, and I look out here at this 2, they are both significant, meaning I measured out to there. Let's compare that for just a moment with over here to the right. I measured all these zeros. They're all significant. But here, I don't have any numbers under them. So what we tend to do mathematically is we put in zeros and we just subtract. That's cool, mathematically. It is not good from a scientific perspective because you're making up digits over here to the right that do not exist. Okay? So when I add these numbers up, I probably have it right below it. I have 9.352 over here on the left, which is correct because those digits are fine. But over here, these digits, I can't bring them down. Right? They just cannot exist. So all I can do is come up with 0.93. Okay, so the bottom line is I line the numbers up, and I look over here to the right, and I see where I have numbers and where I have numbers missing. And if I have numbers missing, I cannot make up those numbers down here in the answer. They have to stay missing. All right, so let's look at these two. You'll notice that up here I have a missing number. I have a missing digit. So even though I can do the math, and when I do the math I can actually put a 0 out there and do the math, you know, I take that and I bring that down to a 4, and that to a 9, and that to a 9, and that to a 10. Right? So my answer is going to be 0.648. But then this number right here is going to be garbage. I can't use it. So even though I come up with 0.648, this number is really a made-up number. So I'm going to round this based on the 8, but then I'm going to get rid of the 8 because I cannot trust it. So my answer is going to be 0.65 to the right number of significant digits. An answer can only be as precise as its least precise number that's used in the calculation. So, what about this one? Well, you have to be very careful here. It can be confusing, right? We notice that this 0, remember this 0 is not significant. It's important, but it's not significant. So when we add these two numbers, we come up with 453, but this 0 really is a made-up number. If it was real, we would have put a decimal point after it, which we did not. So this is going to be, we're going to have to round this. That has to go away. So it's going to become 450. All right. Let's keep going to another example. Now, I'm not going to sit here and do the math out longhand, but look at what you have. You have one digit after the decimal point here, you've got 3 here, and you've got 1 here. So when you're all done, you can only have one digit after the decimal point. So if you think about lining these up, 24.3 and the 19.432 and the 12.2, you only have one digit, so this stuff over here is just going to get lost when I add it all up, because those are your important digits, is the ones digit. Okay? So this 32 is going to disappear. So it's 55.9. Alright, how about this one? Again, looking at the end of the number. Here we have no digits after a decimal point. Here we have 2. Here we have 1. So our answer, when we're all done, we can type it in a calculator, we can sit down and do the math out longhand, but in any case, these digits here, we're going to have to throw away. Now, because the 7 is a 5 or greater, we have to round the 2 up to a 3, so our final answer is going to have to be 453. Let's do another one. Again, here we have no digits after the decimal point. Here we have 2, and here we have 2. Our answer can have no digits after the decimal point. If that's the answer we come up with, we're going to have to round, and the 81 goes away. But we have to be very, very careful, because now all of a sudden we round the 9 up to a 0. Oh, that means we carry 1, and we round that 9 up to a 0. We round that up to a 3, so that's going to be our answer. Well, no, it's not. Because if you look at this, these zeros are simply placeholders. It's not like you measured them. I want to make this last digit, this last 0 over here, significant. And the way to do that is to put a decimal point at the end. So our number is going to be 300 with a decimal point. It's not just going to be 300 without one. Because I need to indicate that this final 0 is significant, this one right here. Okay, and I do that by putting a decimal point. Why? Because this now has 3 sig figs. If I just said 300 without a decimal point, it has 1. So that's why that's so important. What happens if you combine them? Right? By the way, if you're starting to zone out, take a break, pause the video, go get a glass of water, go walk around the house, whatever, then come back. Right? I know this is a long video, gotta be, I can't help that. Alright, so you use your order of operations to determine significant figures and you don't round until the end. Alright? So here's an example. If I take this thing up the top, this is my problem. Alright? And now I'm combining rules. So let's look first at this part over here. My order of operations says the division is done first. So it's just like putting parentheses around it. And if I do a division, what rules do I use? Well, I look at how many sig figs I have here, and I look at how many sig figs I have here, and I can only have 2 sig figs in my answer. So these 2 sig figs are going to be significant to 0.40. Right? Now, I just go ahead and put all this into my calculator, come up with a number. When I add these together, the number that I get is this one. Right? Now, what's the rule for addition? Addition, you say, well, I've got 2 digits after the decimal point. I've got 2 digits after the decimal point. I can only have 2 digits after my decimal point here. So my answer is wrong. My answer should be 3.82. Right. I'm assuming I did that right because I'm doing it live and I don't like the answer that's there. Right. I'll come back and look at that later. On to the next one. How about this? Well, here I have 2 sig figs. I've got 3 sig figs. I get 2 in my answer. That's these 2 right here. And I've got 2 sig figs here. So when I add them, I have to have 2 sig figs in my answer. And you'll notice I end up with 3.46. Okay, and I'm going to lose this one right there. That has another digit at the end, but I'm going to lose it. Alright, how about this one? Well, now notice that your multiplications over here on the left, it comes first. So here I have 3 sig figs and 2, 3 sig figs and 2. So this can only have 2 sig figs, which are going to be these 2 sig figs that are going to be important. Now when I take those 2 sig figs, I'm going to add the entire thing up. Again, if I'm using a calculator, I just add the whole thing up. And now when you're looking at addition, you're saying, well, how many digits do I have after the decimal point? Well, here I have I can't use these. They're all going to disappear. Because I can only have 2 sig figs. So I end there. Here, I do have digits after my decimal point. But when I add them all up, I have something in the ones place, something in the ones place. My answer can only have something in the ones place. I cannot have anything after the decimal point. Right? Let's try this one. Oh, sorry. Alright, so I take 9.90 and I divide by 1.1. So what do I get? Well, I get 9. Be very careful. What I really get is I have 3 sig figs up here, 2 on the bottom. I really get 9.0. When I add that to 17.6, notice that my 0 is significant. I get 6, and then I have to add this, and I get 26.6. Okay. Let's try this one. Here I have 3 sig figs, 2 sig figs, so I can only have 2 in my answer. 9.9 divided by 1.1 is 9.0. And 9.0 plus 1.26. Right, well, notice there's no number here, so I can't use it. So I actually do the math, so I can come up with 10.26. But this 6 is suspect because I made up a number here that didn't exist, and I'm not allowed to do that. So I have to round my number up to 10.3. That's my answer. Alright, try this. Well, here I have, I again come up with 9.0, but now I'm adding it to 11. Ooh, when I add it to 11, what happens? Well, now this number, I don't have a corresponding number after it, so my number is going to end right there. So even when I add it, I get 20.0. This is going to go away, and I end up at 20. Oops, be careful. I have to make sure that we all know that the 0 was measured. So my real answer is going to be 20 with a decimal point to ensure that we all understand that 0 was measured. Alright, guys, you need to know these rules cold. You need to take notes on this. You need to do the worksheets. All of them. I have more worksheets if you need more to practice. Please don't hesitate to ask me. Right? Make sure you do the worksheets. There'll be a video to help you through it. And I will see you in class. Take care. Bye.